Today we're going to talk about one of World War II's most ambitious and honestly lesser-known superweapons, the V-3 cannon. This was a gun designed to do something pretty much unthinkable, and its story is just a fascinating look at the absolute limits of engineering and ambition.
All right, so take a look at this. This is not your standard piece of artillery. Not even close. It's built directly into the earth, and it was a prototype for a weapon of just immense scale and a totally radical design. It went by a few names: the high-pressure pump, Busy Lizzie, and one other, which we'll get to in just a second.
And this weapon, it had one single terrifying purpose. From a fixed position, more than 100 miles away in northern France, it was designed to rain down hundreds of shells an hour on the city of London. We're talking about a relentless, city-destroying barrage.
To really understand how this thing was supposed to work, you have to know its German code name, Tausendfüßler. That translates to the millipede. Yeah, a millipede. So why on earth would you name a massive cannon after a bug with 1,000 feet? Well, that name holds the key to its entire and, frankly, bizarre design.
Now, what's really wild about this futuristic-sounding weapon is that the core concept wasn't new at all. In fact, it was an old dream that engineers had been chasing and failing at for nearly a century.
So how did it work? Well, a conventional cannon, like you see on the left, uses one single massive explosion at the back to propel the shell. Simple, right? But that means the gun has to be incredibly heavy and strong. The V-3 concept on the right is a whole different animal. It uses a smaller initial charge and then a series of secondary charges, those are the legs of the millipede, that fire in sequence, giving the shell a series of kicks to accelerate it along a very, very long barrel.
And get this was not a Nazi invention. If you look at these patent diagrams from way back in the 1800s, you can see American and French inventors were wrestling with this exact same idea. They knew that if they could just master this multi-charge concept, they could build guns with absolutely unprecedented range.
But they all failed. Azel Stors Lyman patented the idea in 1857. Perroc in France followed suit in 1864. But the big test, the real moment of truth, came in 1880 when the U.S. Army tested the Lyman-Haskell prototype. It was a complete disaster.
So here's the critical flaw. The initial explosion, the flash of hot gas, would literally rush past the shell inside the barrel and set off all the other charges way too early. So instead of accelerating the shell, it actually slowed it down. This problem, known as faulty obturation or sealing, made the whole concept a total failure. The idea was basically shelved.
Okay, let's fast forward to the middle of World War II. German engineers, after discovering some of these old plans, became absolutely convinced that they could finally solve those 19th century problems with 20th century technology.
In 1942, an engineer named August Coenders pitched the revived concept, and the goal was just staggering: bombard London with hundreds of heavy shells every single hour. After a devastating RAF raid on the V-2 rocket facility, a furious Hitler gave the project his full backing in May of '43. But just like their predecessors, the Germans immediately slammed into the same infuriating problems with timing the explosions and designing a projectile that was stable.
The projectile itself was a massive headache. This here is the Sprenggrenade 4481, just one of their designs. Because the barrel was smoothbore, not rifled like a normal gun, the shell couldn't spin for stability. It had to be fin-stabilized, basically like a giant dart. You had 6 different companies, including huge names like Krupp and Škoda, working frantically just to create a projectile that could survive the unique forces inside that millipede barrel.
Despite some progress, it all came to a screeching halt in July 1944 at the Misdroy testing site. After firing only a few rounds, the full-scale prototype gun burst. It was the end of the line. The grand vision of a perfectly working supergun was dead. The fundamental flaws were just too great to overcome.
But here's the crazy part. While the engineers were failing to perfect the weapon, an even bigger project was already underway: building the fortress designed to house it. In a hill near Montmouillax, France, a truly colossal bunker was being constructed.
And the site was chosen with chilling precision. It had to be exactly 165 kilometers. That's about 103 miles from central London. This extreme range was the key to its role as a terror weapon. It was all about creating that psychological dread that absolutely nowhere was safe.
And the guns themselves were just immense. Each barrel, buried deep inside this hill, was planned to be 130 meters long.
I mean, that's longer than an American football field, from goalpost to goalpost. Just imagine the engineering required to manufacture, transport, and assemble these colossal steel tubes.
And the plan didn't call for just one gun. It called for 50 of these massive gun tubes, all arranged in clusters and all aimed squarely at London. With a projected rate of fire in the hundreds of rounds per hour, this was intended to be a continuous, unstoppable bombardment, something that would make the Blitz look small.
This drawing here shows what was being built. It was basically a massive underground complex of tunnels, elevators, and ammunition depots, all protected by meters of reinforced concrete. They bored these huge inclined shafts into the limestone hill, all ready to house the batteries of V-3s. It was an engineering marvel, built by forced labor under the organization taut.
But it would never fire. On July 6, 1944, the RAF's 617 Squadron, the legendary Dam Busters, arrived. They dropped 12,000-pound tallboy earthquake bombs. These bombs didn't need a direct hit. They would penetrate deep into the earth before exploding, collapsing the tunnels and burying the gun shafts under tons of rock and rubble. Just like that, the Mimoyekwe's fortress was finished. So the grand plan to level London was in ruins. But the V-3 story doesn't quite end there. The weapon would see combat, but in a drastically scaled-down form that was just a pale shadow of its original terrifying ambition.
During the Battle of the Bulge, the Germans deployed 2 shortened V-3s to bombard the recently liberated city of Luxembourg. And the results? Well, just look at this data. Over 2 months, they fired 183 rounds. Only 44 even hit the urban area. The total casualties were 10 dead and 35 wounded. For a vengeance weapon, its actual impact was negligible.
So what happened to this failed wonder weapon after the war finally ended? The story of the hardware and the sights themselves provides a final, pretty quiet chapter.
And you can really see the stark contrast here. On the left, you've got the weapon in its menacing prototype stage in 1942, and on the right, you see the concrete remnants of a test site today, just slowly being reclaimed by nature. All that ambition and terror has just faded into quiet ruins.
After the war, the U.S. Army captured the remaining gun parts and shipped them to Maryland for testing. But after evaluation, they were just unceremoniously scrapped in 1948. Today, the only places you can really see the V-3's legacy are the museum sites at the ruins of that giant fortress in Mimoyaks and the old test site at Mistroy.
So you have to wonder, was the V-3 just an engineering dead end, part of a desperate obsession with wonder weapons, or was it maybe a concept that was just ahead of its time? While the specific design was an undeniable failure, the core idea, overcoming the limits of chemical propellants to achieve incredible velocity, that didn't go away. The dream of a supergun lived on, echoing in Cold War projects and even in the physics behind modern electromagnetic railguns. It's a powerful lesson in how even the biggest failures can sometimes, somehow, point toward the future.